Hello and welcome to Chemistry 3. Okay, so I'm going to do a few kind of problems that have been to do with the first two episodes. So the question I'm going to pose is what is the composition? It's going to be with atom I was referring to earlier. So number of electrons, protons, and neutrons of neutral atoms. So no ions yet. I'll do an ion question in a minute. Neutral atoms of U235 and U238. Okay. All right. So basically, 235 is basically going to be the mass, right? So it's basically like I mentioned before, it's like that, 235. So what we need to do is, so we know that that's the combination of proton. The mass is the mass, which is denoted by A, is the combination of both protons and neutrons. Okay, so what we need to do to find the atomic number, which is the number of protons in the nucleus, and also it's the number of electrons in the nucleus, we need to do A minus Z, which, as I've said before, is mass, which is the mass, which is a combination of both of them. Z is the atomic number. Now we already know both of these figures, so it's not going to be much of a problem. So we already know basically that this number is 92 because, yeah. So we just do this. So basically, even from that, even just by knowing the fact that the atomic number is 92, we've already got the protons is 92, and we've already got the electrons is 92 because we're not dealing with because this neutral atom means that the protons are 92. Yeah. All right, so we want to get the neutrons though, and I think, yeah, in fact, I already did that as well. So the neutrons is 143. So yeah, and that is that basically. Okay. So next question. What is the composition of the ions of potassium 40 K plus, chlorine 37 minus. All right then. So basically, what do we know first, straight off the bat? Well, we know first of all we're dealing with a positive. We're dealing with the positive ion here. So we know that basically we're dealing with K, and we know the mass, and we're told that the mass is going to be 40. Okay. So let's find out what the atomic number is. So I'm just going to quickly see what the atomic number it is. So the atomic number of potassium is 19. And it's group 1. And that's group 1 atomic number. So it's going to have one in the outer shell, 1 electron in the outer shell. Okay. So yeah. So if we look back, the atomic number. So there'll be 19 in a neutral atom. But we do have a charge on the ion, and we said as well that to get the charge, we basically take the atomic number, which is the number of electrons in a neutral atom, which is the same as the number of protons, which is 19. Why did I do that? Which is 19, and then we simply subtract the charge, and the charge here is 1. Subtract minus the charge, so we're going to get 18. So we have 18 electrons there, and yeah, and the neutrons is simply is basically just 21, because so 18 electrons, neutrons is A minus Z, so mass minus protons, or we could say neutral electrons, but I'll just say protons here. So we look back here and we can see the mass 40, number of protons is 19, 40 minus 19, so we'll get 21 neutrons, and it'll be 19, and obviously 19 protons, because that's the elemental identity, if that wasn't the case. So yeah, really it's best to look at the atomic number as number of protons. So yeah, so we could say that potassium 40K plus has 19 protons, 21 neutrons, 18. I'll do lowercase there. Well, yeah. All right. So there's that. Next up, we've got chlorine 37, and it's Cl minus. Okay, so what do we know first of all? We know that 37 is going to be the mass. It's going to be the combination of the protons and the neutrons. Okay, so we've got a negative. So we don't want to find out. And yeah, we've got the minus here. So we want to find out what is going to be the. So we don't have. So we start off with no protons, no neutrons, no electrons. So let's try and do this in a slightly more structured way than I just did the last one. So we look up chlorine. We can see that chlorine is in group 7 and has an atomic number of 17. Okay. Group 7 and there's an atomic number of 17. So already from there we know that protons are 17. Okay, so to get the neutrons, we just do the mass number minus the atomic number. So neutrons is just going to be 37 minus 17 is 20. And then to get the electrons, yeah, this is actually going to, yeah, I could have done this a lot more simply last time. Then to get the electrons, we simply take the atomic number, or we could, or in this sense, it makes more sense to say it's the number of electrons in a neutral chlorine atom. So that's going to be 17. Okay, and because we're dealing with a negative ion, we add on the charge of we add the charge on the ion for a negative ion. So and the charge is 1. So it's 18. Did I actually subtract the charge for the positive ion? Yeah, I did. Okay, so that's basically the answer. So in chlorine 37, Cl minus, we've got 17 protons. That's the elemental identity. We've got we subtract the mass, the mass number, which is A. So it's A. Say it's A minus Z equals 20 here. So we subtract the mass number, which is the combination of the number of protons and the number of neutrons. We minus the atomic number, which is Z, and remember the atomic number can either be the number of protons or it can also be the number of electrons in an atomically in a neutral atom of that in that neutral atom of that element. And then finally, for the electrons, we use the fact that we're going to have to add, for a negative ion, we take the number of electrons in the which is always going to be equal to the number of protons, and then we add on the charge. So when it's negative, we add on the charge. When it's positive, we subtract the charge, as in the case for the previous one there. Potassium 40, we subtracted the charge to get the number of electrons. So that, as they say, is that. I'm going to be moving on to talking about